Good morning, all. Welcome you all for this session. In this session, we are going to discuss about Wien bridge oscillator. For the last class, we have discussed about RC phase shift oscillator, circuit circuit diagram application, disadvantages, and oscillation conditions, everything. And before entering into the session, just you have to recall what is resonance. Resonance is the condition it oscillates at the maximum frequency and it is called as a resonance. Normally just keep in your mind RC is equal to, that is X is equal to XL. So reactance values are equal. That condition we can say it is the resonance condition. And what is positive feedback? In previous session itself I have informed you, that is we discussed. Positive feedback is the it gives the continuous pulses and it satisfies the Wackelson criteria. And why are sine waves are important? So sine waves are important means normally the frequencies are used for communication system, audio frequency, and testing of electronic circuits. We are using only frequency in the form of frequency, and sine wave does not have a distortions. We are not having more distortions. So this is the basic we are using. Sine wave is important. What is an RC bridge network? RC bridge network actually we know that as resistor and capacitors are together, it form a network that we call as a RC bridge networks. And this is the topic of discussion we are going to discuss. A wide bridge oscillator is oscillator capable of producing very low distortions, and it consists of lag and lead RC networks. And this is the construction. And it consists of operational amplifiers in the circuit. This session we called as the positive feedback session, and this is the one stage of oscillations, and the another stage of oscillations output will be in the output to satisfy the Wackelson, that is oscillation criteria, that is conditions. You have to produce the continuous pulses. So working, first we have to give the supply, and normally the circuit vibrate in a small consists of small vibrations, and after reaches the transistor 1, it phase shift to 180 degree. Then it produces that the output of the Q1 is given to the Q2. Again it produces a shift 180. Then normally 180 plus 180, 360 degree, it shifted and it satisfies the oscillation condition. The output will be again it is given back to the feedback session, and the feedback session consists of series RC and parallel RC networks along with this two resistors, and we are forming a bridge form. It look like a Wheatstone bridge. So it is act as a series resistance area, and C2 and R2 are considered parallel. So the feedback is fed back to the this area. Based on the value of C1 and C2, the resonance will be uh, decided. Why? Because the circuit allows only the resonance frequency. So based on this value only, it can act as it produce the continuous waves, and the positive feedback also satisfied, and it is give the shift. So this is the separately given in the C1 R1, R2 so C2, and R3 C3. In between we are connecting the two stages of CE networks and CS network. And the waveform, you see the waveform, it is time is x-axis, amplitude in y-axis, and it gives the output waveform is 180, that is 180 phase shifts. and it gives the sine wave continuously. And see this particular diagram. In this diagram, the maximum frequency attained the value of Vn is 1/3. So we have to amplify the 3 times of the input voltage, and then only it reaches the maximum frequency, it is resonant condition. The same here, the same frequency, the phase shift is happening. So the value will be, that is the condition will be satisfied of the oscillator conditions. And these are the advantages: high Q factor, low pass noise, high accuracy, excellent temperature stability. And we have to use applications in this point: audio oscillator, function generators, instrumentation, signal generators, electronic laboratories. And these are the real world applications. And the summarization of Wien bridge, we know that it is a type of RC Wien bridge. Wien bridge is a sinusoidal oscillator used in the Wien bridge network, and it amplifies the stable. And for the low distortion frequency, and circuit diagram consists of op-amp and Wien bridge RC networks. And the working principle, it satisfies the Propulsion criteria, and the amplification, it need 1/3 of the resonant frequency. And frequency oscillation, if R is equal to 1/2 pi RC. Advantages and disadvantages are discussed. And thank you all. See you in the next session.